Hello everyone, my name is Ahmadini Abi Abdul Aziz from Group 10, matric number CE210198. Today I would like to show you the result of the question 1. For question 1a, given an expression y equal to ax squared plus bx, obtain an ordinary equation from the expression by eliminating the constant. First step, you need to differentiate the equation a x square plus bx. You get 2a x plus b, and then you differentiate again, you got 2a. So you have equation 1, equation 2, and equation 3. So you get the the value of a, you got y double prime over 2. So you sub the value of a into the equation 2, and then you get 2 y double prime over 2 x plus b, and then you get the value of b. So you get b equal to y prime minus y double prime x, and then you substitute the value of a and b into equation 1, and then you get y double prime over 2 x square plus y prime minus y double prime x and x. Then you want to eliminate the 2 over there, you must multiply it with 2. So you get 2y equal to y double prime x square plus 2 y prime minus y double prime x. And then you move to the left hand side, and then you get 2y minus y double prime x square minus 2 dy prime minus y double prime x and x, and then you expand the negative 2 y prime minus y double prime x and x. So you get 2y plus y double prime x square minus 2y prime x equal to 0. That's it for question 1a. Okay, for question 1b, show that y equal to x power of 3 over 2 plus c over x is the solution for the differential equation dy over dx equal to 2x square minus y over x. Okay, first, we must write the equation y prime over 2x square minus y over x into the form of dy over dx plus pxy equal to qx. So we move negative y over x to the left hand side. So it will be y prime plus x over y over x equal to 2x square. So we get the value of p is 1 over x and the value of q is 2x square. First, we must integrate the value of p. So the value of p will be ln x. So then we find the integrating factor using the formula I equal to exponent integrating the p value p dx. So we get exponent ln x, and then we get the value of I equal to x. Then we use the formula y dot I equal to integrating q multiply with I dx. So we sub the value of I and q, and then we get y dot x equal to x power of 4 equal to over 2. Then we want to eliminate the x beside the y, so we must multiply it with 1 over x. Also, we must multiply 1 over x to the right hand side also. Then you get y equal to x power of 3 over 2 plus c over x. Then this is the final answer. The final answer is y equal to x power of 3 over 2 plus cx. So we have proved the general solution answer. Okay, that's all for question 1b. Okay, for the question 1c, find solution for y prime plus x over 2y equal to 0 using method of separation variable. Okay. First, we must we must move x square y to the right hand side, and then it will be y prime equal to negative x square y. So we separate the y and x value and we move y to the left hand side and x we move to the right hand side. So we move the x from left hand side to the right hand side, and it will be dy over y equal to minus x square dx. So we integrating for both sides, and it will be integrating 1 over y dx equal to integrating negative x square dx. So it will be ln y equal to negative x power of 3 over 3, and then we transform it into exponent, and it will be exponent negative x power of 3 over 3. Y exponent ln y, it can be eliminated in ln and exponent, so it will be y. So the final answer is y equal to exponent negative x power of 3 over 3 plus c. Okay, that's all for question 1c1. Okay, for question 1c, find solution for y prime plus x square y equal to 0 using power series method. Okay. First, we must know the formula of our series. Yx equal to definite sum of infinity and m equal to 0, am x power of m. So we get a0 plus a1x plus a2x square plus a3x power of 3 plus a4x power of 4, and okay. First, we must integrate the value of x. So we get y prime equal to definite sum of infinity and m equal to 1, m x power of m. So we get a1 plus 2a2x plus 3a3x square plus 4a4x power of 3 plus 5a5x power of 4 plus 6a6 x power of 5 and 7a7 x power of 6. Okay, first we must move x square y to the right hand side and we get y prime equal to negative x square y. Then we sub the value of y and y prime into the equation of y prime equal to negative x square y. Then we get a1 plus 2a2x plus 3a3x square plus 4a4x power of 3 plus 5a5 x power of 4 plus 6a6 x power of 5 plus 7a7 x power of 6 equal to negative x square a0 plus a1x plus a2x square plus a3x power of 3 plus a4 x power of 4. Then we expand this equation. Then we get the negative a0 x square minus a1 x power of 3 minus a2 x power of 4 minus a3 x power of 5 minus a4 x minus x power of 6. Then we compare the x from the left hand side and the right hand side. Okay, for x power of 0, we got from the left hand side we got a1, and from the right hand side we got none. So a1 equal to 0. So and then we compare from the right hand side, we compare 2a2x, and then for the right hand side we got also none. So the value of a2 is 0. Then we compare for the x power of 2. We got from the left hand side we got 3a3x square, and then for the right hand side we got negative a0 x square. So we get 3a3 equal to negative a0. Then we will get the value of a3. We get negative a0 over 3. And then we compare for x power of 3. From the left hand side we got 4a4 x power of 3, and for the right hand side we get negative a1 x power of 3. So we get 4a4 equal to minus negative a1. So the value a1 is 0. So the after we move 4 to the left, to the right hand side, we got the value of a4 is 0. And then we compare for x4, we got 5a5 from the left hand side, and then we got negative a2 for the right hand side. As we all know, the value of a2 is 0. So the value a5 is also 0. And then we compare for the x power 5. We got 6a6 from the left hand side equals to negative a3 from the right hand side. Okay. As we all know, the value of a3 is equal to negative a0 over 3. So we get 6a6 equal to a0 over 3. And then we move the 6 from here to the bottom of the a0 over 3, and we get a6 equal to a0 over 18. And then finally we compare the x power of 6. We got 7a7 from the left hand side, and then we got negative a4 from the right hand side. As we all know, the value of A4 is 0. So the value of A7 is also 0. And then we substitute the value of A1 until A7 into the value of Y. So we substitute the value of A0, A1, A2, A3, A4 and A5, A6 and A7, and we get the final answer is Y equal to A0 plus minus A0 over 3 x power of 3 plus A0 over 18 x power of 6. Then we factorize the equation, and then we get the final answer is Y equal to A0 bracket 1 minus 1 over 3 x power of 3 plus 1 over 18 x power of 6. Okay, that's all for me for this question 1. Thank you.
For question 2, we use MATLAB simulation for this question. So this is the coding that we use. As you can see in the coding, the sim function creates a symbolic object that automatically assigned to a MATLAB variable with the same name. Then we write the equation, which is y double prime minus y prime equal to exponent power of 2x minus x plus sin x, and then we run the simulation. After that, we get the answer at the MATLAB. As we can see, the answer at the MATLAB is just like in the manual calculation. Alright, that's all. Thank you.
Good morning. My name is Muhammad Afif bin Ashraf. I'll be answering the assignment, group assignment. Question 3. Given a non-homogeneous system of the first order linear differential equation as shown below, y prime 1 equal to negative 10y1 plus y2 plus 5, y prime 2 equal to negative 20 over 3 y1 plus 98y2 over 15 plus 10 over 3. So the first question is asked to evaluate the general equation of the homogeneous system. And the second one be determine the particular integral for the non-homogeneous system. C. Formulate the general solution for non-homogeneous system. D. Calculate the particular solution for y1x and y2x with y0 equal to 1, negative 1. So firstly, we need to write in matrix form of y prime equal to ay plus d. So as we know, a equal to negative 10, negative 20 over 3, 98 over 15. Y plus g equal to 5 and 10 over 3. For step 2, we need to find the eigenvalue and the eigenvector. So back to step 1. After we write the matrix form of y equal ay plus g, then we take out the value of a and we put the negative lambda at negative 10 and 98 over 15, which is the formula of this solution equal to 0. Then after we add a negative lambda on this side, then we do a cross multiplication with the after we do a cross multiplication, then we subtract the value. Okay, after that, after we simplify all the answer, we need to factorize so that we can find the value of lambda, which is negative 0.5 and negative 3.0. And the answer is I convert into a decimal places, one decimal places. So for next step is we sub the value that we get, which is the negative 0.5 and negative 3.0 to lambda. We sub the value of lambda equal to this particular value. So after we sub the value and the answer and the answer will be y equal to 0.5 0.95 s. And not to forget that before we solve, we need to change the value, the variable x into s, so that it so that it meet the characteristic of the eigenvector. So after that we get the eigenvector value x equal to 1, y equal to 0.95 positive. So for negative 3.0, we set the value like we did in this part, negative 0.5. We sub the value, and not to forget that the way how we calculate this value is by plus firstly negative 10, negative 3.0. So firstly we settle down this part. Negative will be positive, negative will be positive, then positive. So for this part is same as this one. Just replace the lambda with negative 3.0 and we simplify. So how we simplify is so for example this part, negative 10, negative, positive 3.0. So negative 10 plus 3.0, we get 7.0, and 7.0 we times by x. And for this part, 10 times y. So how and this how we get, and equal to 0, not to mention this part times this part times this part, and equal to 0. If the this part is equal to 1, then if this part is equal to 0, then it will be equal to 0. If this part is equal to negative plus 1, then this one will be plus 1, same as both, same as this part also. This part times by this part, and this part simplify first, then we times to this part equal to 0, and same as this part, turn change x equal to s. Then I take the first equation so that I can find the y. We can also take the value of this part also to find the y. The answer will be same. And after I simplify, the answer will be 0.7s. And the eigenvector is x equal to 1, y, which is we get from here 0.7s, as we put outside. So the next step is find whether the equation is linearly independent or not. When it comes to linear independent or not, if the answer is equal to 0, then it will be linearly independent. If not equal to 0, then it's not linearly independent. So for this part is how we solve if 1 times 0.7 minus by 0.95 times 1. Then we simplify, we get negative 0.25, or also equal to negative 1 over 4. Yeah, negative 1 over 4 is not equal to 0. It's not same. It's not same with 0 or not equal, so it will be linearly independent. And step 4, obtain the general solution for YC. All the explanation from step 1 until step 4 until step 3 is to find the value of YC. After we get all the value, then we obtain the general solution, so which is YC equal to C1 0.5 exponent negative 0.5x, C2 0.7 exponent negative 3.0 x. So the value of this part negative 0.5 and 3.0 we get from here, lambda. And for this part 0.95 we get from here. And for this part C2 0.7 we get from here. So that the final answer for question E. So for question B, determine. So question B, we need to find determine the particular integral for non-homogeneous system. Okay. Determine a particular integral for non-homogeneous system, which is YP. We need to find YP in step 5. At previous step, we need to find YC. This part is we call it YC. And for this part is we need to find YP. And soon we will comparing the value of YP and YC. So to get the value of YP, we need to take out the value of G, which is 5, 10 over 3, where we get this value from the question, 5, 10 over 3. So by referring the table based on G at our module, if the value of YP given is not same with YC, we will proceed. And if the value is same, then we need to times x and plus we need to put the additional variable, which is from u1 plus v1x and u2 v2x, we times with x, the v2 value. So after we get the value of YP, then we compare with YC. Is it same? No, because there is no exponent in YP, so the YP is not same with YC. Step 6, obtain the Y prime P. So to get the Y prime P, we need to differentiate the value of YP. So by differentiate the value of YP, we will get the 0, because there's no X in here. Okay, for step 7, yp prime equal to ay plus g. Then this is the formula. After we get the value of the yp prime, then we need to sub back into the yp prime equal to ay plus g, which is, this formula is actually from here, this part. This part is belong to yp. We sub the value back. So after we sub the value, we will get this one. So the value of yp prime and y is yp, this part. Then after we sub the value, then we do the product, the multiplication of matrix form. 95 times u1 plus 10 u2 plus 5 equal to 0. 0 we get from yp prime. Then after that, so for this part, I take from the upper one. The lower one I didn't take. Actually, if we take, we get the same answer. Okay, to find the u1, uh, let u2 equal to 0. The easiest way to find u1 is to u2 is we sub into 0, after that, so for this part, negative 10 u1 plus 10 u2 equal to negative 5. Negative 5 where we get from here. So this part is plus 5 equal to 0. So the value without the variable we put after we put we we transfer into the other side, and it will be change the polarity of the value. For this part is positive. After we place at the right side, it will change it into negative. That's how we get. And not to mention, we set the value of u2 equal to 0. Then we simplify, we get u1 equal to 0.5. Then yp is equal to u1 and u2 0.50. Or for easiest way to understand is u1 is equal to 0.5, u2 equal to 0. So this is for step 7. So this is yp. Yeah. Okay. So for C, step 8, obtain a general solution, which is yc equal yc plus yp. So we sub the value back. yc is here, c1 1 0.5 exponent. This part is lambda, the value of lambda, which we have to lambda, and this one is the value of eigenvector of, this is the value, or this is the eigenvector for value negative, for lambda equal to negative 3.0, and this part is for the value of eigenvector 0.5 for the lambda negative 0.5, and this part is equal to yp, which is u1 and u2. We sub the value back. so uh so for question C, we solved the question C already. Okay, for step D, which is step 9. The question given the actual value, sorry, the initial condition. Oh, the question is given the initial condition with y 0 equal to 1, negative 1. And the easiest way to understand this question, this particular initial condition, is this part will be the value of x and this part will be the value of y. So I wrote it down. X equal to 0, y equal to 181. And after that, I sub all the value. I sub the value of x and y, y which is at here, and x here to here, x equal to 0. Then I sub all the x at here equal to 0. So it will be the 0. And y1, negative 1. So after that, after we sub the equal to 0, the value will be exponent 0. So the value of the exponent to the power of 0 is 1. So I didn't write here. I just simplify. So after that, from here, 1 equal to C1. I'm sorry, I didn't write it down. C1 times 1 times 1. We know that exponent 0 equal to 1. And for this part is also plus C2 times 1 times 1. So any value that times 1 will be, we get this C2 back. Plus 0.5. Same goes for this part. So this part will be equation 1. So for equation 2, this part, the lower one, so this part will be equation 2, and this part, I take the equation from 1 and I put the C1 in front. So and the value is after the equal. The simplest thing I can say is we find the C1 from the equation 1. So the equation 1, the C1 is 0.5 and negative C2. C1 equal to 0.5 negative C2. That will be equation 3. After that, to find the value of C2, we sub the value 3, which is C1, we already know, into 2. So we sub back the value 0.5 C1. So C1 equal to 0.5 negative C2. So we sub back and then we simplify. We get 5.9. C2 equal to 5.9. Then after we get the value of C2, we sub back into 3, which is here, to find the C1. Then the answer is negative 5.4. And lastly, we sub the value of C1, C2, which is from here. After we get the value of C1 and C2, we sub the value back. So negative 5.4 and 5.9. Then we simplify. Negative 5.4 times 1. Negative 5.4 times 0.95. So that's why we get this value. Same goes to this part. 5.9 times 1, 5.9 times 0.7. So that's from me. Thank you. So next, I'll be solving the question, which is question 3, by using the software, mathematical software, which is Maple. Sorry. So I wrote back the question. D per dx y1 x, and this part is y prime. And if I write the y prime, and it will appear the same the same the same formula here. So next step is we find I put A, and you can put any word B, C, D, as long as you put this double dot here before the equal. So we store the value, and for this part we need to find lambda, and we simplify, and the answer will be same as the previous one, which is here. So after that, uh, we put the eigen. I write down the eigen A equal to eigenvalue A. So eigenvalue A is here. Eigenvalue A, the small a, is here. Actually, the easiest to understand is actually the value of lambda is already been sub. Value of lambda which we get previously, we sub back, then we minus. Sorry. So next we find the yc after we get all the value given. C1 is equal to 0.95 in my manual calculation. This part will be a bit different since I take only one decimal place, and for Maple they will take all the value. So that the yc is here. To find the yc, we we take all the value, which is C1 times V1. V1 is from above, we get exponential exp here, eigenvalue A and x. Eigenvalue A is the value of lambda. We got two value of lambda, negative 0.5 and negative 3.0 from here. Okay. For this part, we need. So for this part is answering the question 3a. For this part we will find the answer. We will solve the answer B to find the yp. Then after so for find the yp, we take it out the value of g from the question, which is 5/10/3. We wrote it down back. Then it will appear this. So we know that yp is not equal to yc. So the formula, so I write down manually. Here u1 bracket 1 and u2 bracket u bracket 1 u bracket 2, because this is a value of yp from the table based on based on g. So for this part is we differentiate the value of yp, which is we get from the table, which is equal to 0. For this part, I sub the value back all the value given, which is yp prime a y plus g. So this part is yp prime, this part is a, this part is yp, and this part is g. I sub the value back. And simplify, and it will appear this. All the value are all from the above. I just sub it back. No need to write down all the equation. So for this part, we need to find the u1. To find the u1, the u2 we need to equal to 0, as I mentioned in manual calculation. So to find u1, to find the u1, we transfer all the value given. For this part is the upper one. For this part is the lower one of the matrix form. Then we solve. Then we get this particular value. So for this part, I wrote down the value here. We know that u1 is upper and u2 is lower of the matrix form. So for this part, we know the value of yc from the above, and the yp we get from here. So after that we set all the value and appear like this, because in Maple we don't need to type all the value, since we already declare from above. So for this part is the initial condition is given from the question 181. So this part is for the upper one, which is 1 and -1, we get from the initial condition. So I sub the value back from the previous answer at here manually, and then I solve the equation, and I write down the solve equation z and equation y. So it will solve the value here, and we get this value. And lastly, And lastly, I put it down back all the value that we get, and the answer will be here. Actually, this answer is y. The answer is y equal to C1. This part is C1, and this part is the lambda, and this part is C2, and this part is the lambda, and this part is G. Since we know all the value, so just sub back to this question, this equation. This part is C1, and this part is C2. That's all from me. Thank you.
Assignment for question 4A that has been given to us. The question is, given a differential equation, y prime double prime minus 8 prime plus 3y plus a equals ft, where ft is a predicate function as shown in figure Q4a. First, they want us to find the piecewise function of ft. Second is find the Laplace transform ys on a different equation with initial values when t equals to 0, y equals to 1, and y prime equals to -2. Solve it manually. If we see from the graph, we can say that uh, 0 less equals than t equals t, and 1 less equals than t less than 2 equals to 1. So from that we can summarize that ft equals to t equals 0, t less than 1, and the next is 1 less equals than t less than 2. And for question 2, to get the ys, we must calculate the Laplace transform ft. From less than 0, t less than 2, ft is represented by xt. xt equals to micro t minus micro t minus 1 minus u t minus 2. Take the expression, and t equals to 2, xs, get it, and take the Laplace transform at a 1 to get the answer. After that, we take the Laplace transform at differential equation to solve and get ys. So that for question B, a series RL circuit is shown in figure Q4b where R 10 ohm and L is 2 Henry. The source to the circuit is given as Vt equals to e negative t, 2 exponential negative t, t minus 1, h t minus 1. By applying Kirchhoff's law, show that circuit can be represented by following equation. Dit over dt plus 5it equals exponential negative t, t minus 1, h t minus 1. And next one is to determine the circuit it for the circuit using Laplace transform with initial condition I 0 equals 0. For manual question B1, by applying KVL, we can first find VR and VL in series circuit. After that, we expand the expression, and then we can put it the value of R and L, 10 and 2. And we can put in the value of V. Then we simplify the equation to get 5I dt plus di squared dt equals e negative t minus 1 h t minus 1. And then we can arrange it to get dit over dt plus 5it equals e negative t exponential negative t minus 1 h t minus 1. After that, we can solve the Laplace to get the answer of is 1 over s plus 5 bracket negative ds h s plus 1 exponential negative s plus 1 minus h s plus 1 exponential negative s plus 1. That we can take inverse Laplace transform and solve to get the value of it. For the question for A and B, we are using more mathematical software Maple to determine the plot of the graph of piecewise function from question 4A1. And then we calculate the for question 4B. We can first determine the R, L, and V. After that, we complete the equation to get the answer as we get from the manual calculation. And this is the answer for question 4B if we calculate it using Maple. That's all for us today. Thank you.